Ashraf.
So hello guys, this is for our MES presentation, and we have choose option 5 as our option 5 as our MES presentation. And so our group is group 96, which consists of our teammates Brandon, Akmal, Joel, myself, Ashraf, and Indra. So me and Joel will be presenting for you today. So for our project, we got 3 parts, which is part 1 is more of differentiation, part 2 more of integrating, as well as part 3. Part 2 and 3 basically part 2A question 5, part 2B question 5. So for part 1, we will be doing differentiation to find the change in dosage with respect to patient's weight. And for part 2, I pass over to Joel, which is he will be focusing more on integrating to find the nicotine concentration in bloodstream when the patch is on, as well as part 2B when the patch is off. So for part 1, the questions given is the formulas given for the dosage for chemotherapy drugs for female patients. So as you can see here, we need to determine the change in dosage D with respect to patient's weight for 40 years old woman. So the equation given here is D is equal to 0.85A bracket square root C plus 25 and C, which is shown here too. So for the constants given are A and X, which is drug specific parameters. So we use equation C, which is with sub y is equal to 40. So what is 40? 40 is the age of the woman. So we'll be solving using equation C to solve the creatine clearance, and C is equal to 140 minus 40 and so on. And this is our answer. This is what we get here. And moving forward, we are going to do differentiation for the equation D itself. So by substituting creatine clearance C into dosage equation D. And this is what we get here. So I'll be passing over to Joel, and he'll be focusing more in calculating the concentration and nicotine in bloodstream.
So part 2, as Ashraf has mentioned, is finding the concentration of nicotine in the blood plasma, which is N, and this can be modeled by the following differential equation. It can be modeled by the following differential equations. So part 2 has 2 parts. 2A, which is to find the concentration of nicotine in the bloodstream for when the patch is applied for 16 hours. And later on, part 2B, which is to find the nicotine concentration in the bloodstream when the patch has been off for 8 hours. So the equations given in the question are dN over dt equals to N naught plus Kn for when the patch is on, and dN over dt equals to Kn for when the patch is off. Constant variables given in the question are K equals to negative 0.15. So in order to solve the equation, the question in order to solve part 2A, we need to integrate the equation for when the patch is on, which is dN over dt equals to N naught plus Kn. And we need to sub in K equals to negative 0.15 as it is a constant variable given in the question. So doing so will result in the equation T minus 0.15 NT. So in order to solve part 2A, we need to also substitute T equals to 16 into the integrated formula of when the patch is on. And as you can see, this gives us the result 4.71 micrograms per liter, round off the 3SF, which is our final answer for the nicotine concentration in bloodstream at T equals to 16. Part 2B, which is to find the nicotine concentration in the bloodstream at T equals to 24 hours. requires us to use the second equation, dn over dt equals to kn. So we need to first integrate the equation for when the patch is off. And once again, we need to sub in k equals to 0.15, negative 0.15. And in order to solve the equation, we need to sub in t equals to 24 into the integrated equation for when the patch is off. And this gives us the result of 2.14 micrograms per liter, which is our final answer for the nicotine concentration in the bloodstream at t equals to 24. We have come to the end of the presentation. Thank you for your attention.